Hi everyone, and welcome back. So as you saw in our previous lesson, we were talking about exponential growth and decay. So now if you remember our general formula of y equals ab to the x, where we said a represented that initial amount, and we said that b was representative of the base. And then x was just our variable. Okay, now we talked about how if this value here is greater than 1, it's a growth. And if it's less than 1, it's a decay. All right, very important, we're going to need to know. All right, so if b, again, is greater than 1, we're looking at a growth. If it's less than 1, then we're looking at a decay. And a is that initial amount. We also know that that is representative of the y-intercept. Y-intercept is always written as 0, comma, whatever the y value is. So remember, y-intercept is when x always equals 0. All right, so let's take a look at this first example. So we have the NCAA Basketball Championship, also known as March Madness, is an example of an exponential function. At each round of the tournament, teams play against one another with only winning teams progressing to the next round. So in other words, the number of teams playing at each round is half of the number of teams playing in the previous round. So let's start with 64 teams going into round 1. We're going to complete the table and see how many are left when we go into round 6. All right, so again, we're just having those numbers. So half of 64 is 32. Half of 32 is 16, right? Because we said we want to be having the numbers, and we should underline that here, half. Half of 16 is 8, half of 8 is 4, half of 4 is 2, and half of 2 is 1. Okay? Now, if I continue to keep having this number, guys, if I half 1, well, half of 1 is 1/2. If I half 1/2, that's 1/4. Notice you will never reach what number? If I just continue to half and half and half, you're never going to reach 0. This number will just keep having. Okay, so just keep that in mind. We're never going to reach 0. All right, so let's come up with that pattern. So we have the pattern is 64 over 2 to the 0. I have 64 over 2 to the first. I'll have 64 over 2 to the second. And the pattern will just continue, so I'm just going to fill that out. All right, so this is what your table should look like. So let's actually start to plot these points. I have a point at 0, 64, 1, 32, 2, 16, 3, 8, 4, 4, 5, 2, and then 6, 1. All right, and again, we're going to connect them with a nice smooth curve as best you can. And there we go. Again, notice this will never cross over the x-axis. If I did this, that would be wrong. Okay, remember, there's that asymptote at y equals 0. It's never going to cross over the x-axis. All right, so let's continue. Again, remember, this is representative of an exponential function. Exponential. And is this a growth or a decay? Good, this would be a decay. So that b value, if I were to write my equation ab to the x, this better be less than 1. All right, let's keep going. Okay, now we already kind of talked about this. Again, we have any quantity that grows or decays by a fixed percentage or by regular intervals is said to be an exponential growth or an exponential decay. So for the exponential growth, now for you guys, for the regents, you have to memorize these formulas. They will not give them to you. So you need to know the difference between an exponential growth and decay, and it's not too complicated. All right? So just remember what we said. For that exponential growth, this value here is going to be greater than 1. And then for the decay, this value here has to be less than 1. Notice the addition, meaning it's going to be bigger, than the subtraction. Okay? All right, so we actually already stated this before. All right, you should notice that the growth or decay factor our b value, so our b value being that growth factor, it's now being replaced by 1 plus r or 1 minus r. All right, so we're actually going to be writing y equals ab to the x now like this. Y equals a times 1 plus r to the x if it's a growth. All right, so this would be for a growth. And I'm also going to be writing y equals a times 1 minus r to the x. And now this would be for a decay. So keep that in mind. Now we're switching over to these two formulas. All right, so a, we already said this before, that's our initial amount, also representative of the y-intercept. We have r is the growth or decay rate. So r is now our growth or decay rate. It's most often represented by a percentage or a decimal. This is going to be really important. And then x just represents the number of time intervals that have passed. So let's actually take a look at some examples. All right, and here I highlighted our formula. Again, you need to have this memorized. The Regents will not give it to you. So you have to know y equals a times, it's either going to be 1 with a plus or a minus of the rate to the x. All right, so let's look at the first example. And you'll have to determine whether it's plus or minus depending on the scenario. So if it's a growth, you're going with plus. If it's a decay, you are going to go with minus. All right, so growth, you'll have a plus. You'll have a plus. And then decay, you'll have minus. All right, so let's take a look at the first example. We have the initial value of 50 is growing. So when you see growing, I'm going to write down that formula. Y equals a times 1 plus, because it's growing, to the x. Okay, 1 plus r to the x. We know it's growing at a rate of 23% each year. We want to come up with the equation after t years. So instead of using x, we're going to use t. All right, so a is our initial amount. We see that initial amount is 50. The rate is 23%. Now, we need to write that as a decimal. When we write percentages as a decimal, technically this is 23.0, right? We move the decimal to the left twice to get the decimal value. So the rate here is 0.23. And now to come up with our equation, we have y equals, well, our a value is 50 times 1 plus, the rate is 0.23, and we're raising it to the t. So that's our equation for a growth. Okay? All right, now let's take a look at the next example. We have the initial value. So again, let's highlight over that. Initial value, 14, so that's our a, is decaying. So now we're looking at a decay. So we have to remember that formula now. Y equals a times 1 minus r to the x. You got to know the difference. If I say I'm talking about a decay situation, you have subtraction in the middle. If I'm talking about growth, you have plus in the middle. You got to read. All right, and these are two formulas. Again, you need to know for the Regents. They don't give it to you. All right, let's keep reading. We have the decay rate is 7%. So I'm going to write my decay rate is 7%. But now I need to change that from a percentage to a decimal. So this is really 7.0. I'm going to move the decimal over 2 places. This placeholder here means there's a 0 here. So this is equivalent to 0.07 as the rate. All right, now we just have to fill out our equation. Be careful, it wants you to use t as in years. Again, Regents will take off a point for using the wrong variable. So we're going to write y equals, a is our initial amount, 14 times 1 minus, because it's a decay, 0.07 to the t, and that's it. All right, you just got to remember, the growth rate is r, which is determined from 1 plus r, and then the decay rate, r, is determined from 1 minus r equaling b. All right, so let's come up with those percentage of change here. So let's look at a few examples. All right, so for the first question, determine if each of the following equations represents an exponential growth or decay, and we're going to circle them. So I'm going to do question letter A and letter D, and I want to see if you can figure out the other two. All right, so for the first one, we have y equals 2 times 1.25 to the x. So I'm going to do A and D. You're going to figure out B and C on your own. So you'll pause the video there. So first things first, write out your equation. Y equals A times 1 plus or minus r to the x. Now remember, y equals A times 1 plus r to the x. This would be a growth. And then what would be the formula for decay? What's our decay going to look like? Good. A times 1 minus r to the x. All right? So keep that in mind. We need to know our growth formula and our decay. All right. Well, notice how the number that represents b is greater than 1. So because that number is greater than 1, this is going to be a growth. Now the percentage of change. I want to know the percent this went up by. So if this could really be rewritten as 1 plus r, right? How much bigger than 1 is that number, guys? How much bigger than 1 is 1.25? It went up by 0.25. There's a difference of 0.25, right? So if I'm looking at the number 1, I want to know how much bigger, if I'm looking on a number line, how much bigger is 1.25 from 1? Well, there you go. There's that difference of 0.25. So now I have the rate, but I want that written as a percent. So to go from a decimal to a percentage, we're going to move that decimal to the right twice. So this is equivalent to 25% growth. Okay. Now let's take a look at letter D. Again, you got to check that B value. So this B value, is it bigger than 1 or less than 1? That's always what we're comparing it to. Bigger than 1 or less than 1? Well, this number is less than 1. So it has to be a decay. And now think of a number line, guys. If here's 1, here's 0.9. How much smaller is 0.9 from 1? What's that difference? 0.10. Again, you can put that in your calc, guys. 1 minus 0.9 is 0.10. So that's the decimal rate. But I want it as a percentage. So remember, you got to move that decimal to the right twice. So this is a 10% decay. It's a 10% decrease. All right, so I'm going to erase what's on my screen here because I want you guys to give letters B and C a try. So pause the video here, give question letters B and C a try. Give it a go. All right, so I know this may look a little bit sloppy. It's just kind of hard to write on the screen here. So for letter B, you should have had it's a decay because this number here is less than 1. All right, and how much less than 1 is it? Well, it's a difference of 0.08, which we can rewrite as a percentage as 8%, and it's an 8% decay. For question letter C, we have this number is greater than 1, so you know you're looking at a growth. And how much greater than 1 is it? Well, if we look at our number line, it's a difference of 0.1. So if I write out 0.1 and change it to a percentage, you're looking at a 10% growth. All right? Okay, let's keep going through again. All right, so for question 2, we have a flu outbreak hit DMS on Monday. So, all right, so we have a flu outbreak, and it has an initial number of 20 ill students coming to school. So we have 20 ill students. The number of ill students increases by 25% per hour. So I want you to think, would this be an example of something as a growth or a decay? So we have a flu outbreak, there were 20 ill students, and the number of ill students is increasing by 25% per hour. So what would this be an example of? This would be an example of a growth. This is an example of an exponential growth. Something like this does not grow linearly. So that's really important. On the Regents, they tend to ask whether it's linear or exponential, right? When you're talking about something dealing with like bacteria, the flu, when you see the words doubling, tripling, etc., you need to be thinking about exponential. They'll throw in linear just to kind of trip you up. All right, so be careful. All right, so what kind of function would model this? Well, let's see. How are we going to come up with our equation here? we initially start out with 20 students. So there's my A value. We start off with 20 students. So I have y equals 20 times, you said it's a growth. So we're looking at 1 plus something. How do I rewrite 25% as a decimal? Whenever you guys write this number here, it has to be a decimal. This must be a decimal. All right. So 25% as a decimal, we got to move that decimal point 2 points to the left. So this would be 0.25. 0.25, and it's just being raised to the x. Okay? And the question asks about how many students will be ill after 6 hours. Well, what does x represent? You need to know x here represents hours. So we're just going to plug this in. Okay, so I'm plugging in my 6 here for x because I want to know after 6 hours. And when I put that in my calculator, I get 76.29394 ... Now, we have to be careful with rounding. All right, so we would round this to really how many students? How many students? All right, so this would be approximately 76 students. All right, you can't have 0.29 of a person, so we're just going to round that to 76, okay? All right, why don't you guys give question 3 a try? So I would pause the video here. All right, you got to make sure you remember our equation for an exponential function. Remember, you've got this is for growth, and then this one is for decay. So see if you can come up with, for number 3, letters A and B, what the answer is going to be. So pause the video here and give it a try. All right, so given this equation, first thing I'm paying attention to is this number bigger than 1 or greater than 1? This is greater than 1, so we know we're looking at a growth. All right, that helps us narrow down maybe some of our choices here. Okay, now the question says, what's the initial value? Well, the initial value is always your A value, so that's just 50. It's the number out front of B. And it says, what is y to the nearest tenth when x is equal to 0? Well, guys, you have a calc. Just plug this in. 50 times 1.15 to the third. And when you put that in your calculator, you end up getting what's closest to 76. So that would be 76. Okay? All right, let's keep going. Just getting more practice. All right, so let's take a look at question 4 here. We have a new sports car sells for $35,000. The value of the car decreases by 18% annually. So this is decreasing by 18% annually. Which of the following choices models the yearly value of the car? So just so you guys know, the word annual is another way of saying yearly. Annual is the same thing as saying yearly. Just some important vocab you need to know. All right? So we have it sells for $35,000. So what does that represent for us? It sells for $35,000. Good. That's your A value. So I'm going to write out my equation. Y equals A times 1 plus R to the X. That's for your growth. And let's write out our equation for the decay. A times 1 minus R to the X. And that's your decay model. All right. So I have Y equals that 35,000 times, is this going to be 1 plus or 1 minus? Well, let's see. We always know we're going to have a 1 here to start, but is it plus or is it minus? Well, it's decreasing, so we know that's going to be minus, all right? And it's decreasing by 18%. So how can I write 18% as a decimal value? Good. You move that decimal to the left twice. So that's 1 minus 0.18. Okay, now that's our final answer. Now, if you look at your answer choices, I don't see that. Well, guys, you just got to take another step here. What's 1 minus 0.18? All right, so I'll say it again. What's 1 minus 0.18? Just put that in your calc. Good. You should end up getting 0.82. So this answer choice is equivalent to answer choice 3. All right, so what I would like you to do is pause the video here, and I want you to give questions 5 and 6 a try. 7 we'll do together, but I want you to do 5 and 6 on your own. So again, I would pause the video here and see if you can give those a try. All right, and there you guys have it. So for question 5, this ended up being a growth. So we're looking at that 1 plus. I converted our percentage of 2.4 to a decimal. So 2.4, we moved that decimal to the left twice. And we threw that in here for our rate. All right, and that answer choice ended up being 3. If I look at question 6, now this one's just a little bit more work. I want to know which one's the decay. So in order to figure out which is the decay, again, you guys got to remember, we're looking for which value inside the parentheses is less than 1. So we want inside the parentheses to be less than 1. Well, so if you look at answer choice 3, this is bigger than 1. 1.09 is bigger than 1. If I look at answer choice 4, again, 9 is bigger than 1. If I look at answer choice 1, 0.9 is less than 1. So it has to be answer choice 1. And the reason why, again, is 0.9 is less than 1. So it has an exponential decay, and it's actually decreasing by 10%. Because if I compare 0.9 to 1, there's that decay, that decrease by 10%. All right, I can move that decimal to the right twice, which is equivalent to 10%. Okay? All right, let's just keep going. Okay, let's take a look at question number 9. So this is actually a regions question, so let's read this carefully. We have the population initially has 20 birds, and it approximately doubles every 10 years. So remember what I said, when you see doubling, halving, when you see tripling, okay, etc., it gets cut in half, it multiplies by 2, you should be thinking exponential. Do not fall for the trap of linear. So not linear. Okay, things that double and triple are not linear. Linear is that constant rate of change. So an example of that constant rate of change would be somebody that gets paid $7 every day. Or another example would be of something linear is making 10 cookies a day. So making 10 cookies a day. All right, so that's the difference between linear and exponential. Exponential is, again, that doubling, halving, tripling, etc. All right, so we have this population initially has 20 birds. So we're starting off at 20. So let's look at our graphs. We want to be starting at 20, that y-intercept. So the only example that doesn't start at 20 is 1. So that's out. Even though this graph is exponential, this is not starting at 20. It's starting at 0. So this example, this answer choice is out. All right. We already know that this is exponential because of that keyword doubling. So I'm going to get rid of answer choice 4. Because also it's that example is linear. We want exponential. Has to have a nice smooth curve. All right. All right, now let's see. It's doubling. So there should be more birds over time, not less. So look at the main differences between answer choices 2 and 3. For answer choice 2, it's showing I start off with 20 birds and I'm getting close to almost none. For answer choice 3, I'm starting off with 20 birds and it's growing and growing and growing. And we're looking at something that doubles, so it has to be answer choice 3. All right, again, that was just a regions question, just so you guys have an idea. All right, let's just keep going. Let's take a look at example 12. So we have Mr. Smith invested $2,500 in a savings account. That's his initial amount. So there's your A value. A is equal to $2,500. His savings account earns 3% interest compounded annually. Remember, annually means yearly. All right? He made no additional deposits or withdrawals. Which expression can be used to determine the number of dollars in the account at the end of 4 years? Now, guys, when you see a question like this, notice that there was no keyword there of growth or decay. However, when something is earning money, it's earning interest, that means the account is growing. So when you see you earn interest, that's good. When you earn interest, the account is growing. So you are thinking of that growth and decay. So I'm looking at this example. Y equals A times 1 plus R to the X. We're going to have that plus. So any answer choice in here where it's less than 1 is out. All right? So let's take a look. We have that initial amount of the $2,500 times 1 plus, because it's a growth, 3% interest. How do I rewrite 3% as a decimal value? We have to move the decimal place over. Is it to the left or to the right? When you go from a percentage to a decimal, you move it to the left twice. So this is plus 0.03 to the X. Now, it wants to know after 4 years. So what does X actually represent? 4. So there's my final equation. 1 plus 0.03 to the 4th. And the only answer choice that is the same as is answer choice 1. So this is the same as answer choice 1. All right, so for those of you guys that like that extra practice, I am going to go through a few more examples if you want the extra support. So stay tuned. All right, so let's take a look at example question 13. So we have Cassandra bought an antique dresser for $500. So we have the $500. Again, I already know that's the starting amount. So that's my A value. That's the initial amount I paid. Her value of her dresser is going to increase by 6% annually. So it's going up by 6% each year. It's going up. So I know I'm looking at a growth. So this is going to be my equation. A times 1 plus R to the X. And we want to know what will be her value of the dresser at the end of 3 years. And we're going to round that to the nearest dollar. Okay, so guys, let's just plug in. I have my initial amount is $500. It's going up by 6%. How do I rewrite 6% as a decimal? We move it to the left 2 places. So I have 1 plus 0.06 to the, and it wants to be after 3 years, so to the 3rd. Type this straight into your home screen on the calculator. When you type that in, this is what you end up getting. 595.508 ... But I want you to round it to the nearest dollar. So when I round this to the nearest dollar amount, the 5 is going to make this 5 turn into a 6. So I'm going to be looking at 596. All right. So that answer choice is answer choice 3. All right, awesome. Let's just keep going. So for question 14 here, we have in a science fiction novel, the main character found a mysterious rock that decreased in size each day. So we're going by days here. The table below shows the part of the rock remaining at noon on successive days. So day 1, you have the entire rock. That's why it's starting at 1. All right. On day 2, we see half of the rock. Right? On day 3, I see a 1/4 of the rock. And on day 4, I see 1/8. So we went from 1 to a half to a 1/4 to an 1/8. Do you see a pattern? This is not linear. Remember, linear means constant rate of change. This is not decreasing by a constant amount. If this was linear, it would be being subtracted by a half each time. But it's not. Right? We have 1/2. This would have then needed to be 0 if it was linear, but it's not linear. So what are we actually multiplying by? What is each value being multiplied by? How did I get from 1 to a half? How do I get from a half to a 1/4? And how do I get from 1/4 to 1/8? What am I multiplying by each time? Good, you're multiplying by a half each time. So my exponential decay is this thing is decreasing by a half. It's decreasing by multiplying by a half each time. All right, so now the question says, which fractional part of the rock will be remaining at noon on day 7? So guys, we just need to continue this pattern all the way to the 7th day. So if on the 4th day, we had 1/8 remaining, and we want to get all the way, so we have 4, 5, 6, 7. We want the 7th day. So on the 4th day, we had 1/8 remaining. And remember, we're multiplying these by 1/2. So on the 5th day, we'll have 1/16. Again, multiply by 1/2. I'll have 1/32. And then again, multiply again by 1/2, and I'll have 1/64. So there's my answer. I'll have 1/64 remaining. All right, let's take a look at questions 15 and 16, and I think we'll call it a day. All right, so for question 15, we have a car was purchased at $20,000, and it's decreasing. So there we go. I already know I'm looking at a decay. So my formula for decay is I have y equals a times 1 minus r to the x. We know it was purchased for $20,000, so there's my a value. Okay. And it's decreasing at a rate of 12% per year. I want to know what will be the value after 3 years. So how can I rewrite 12% as a rate as a decimal? So again, we got to move that decimal place to the left twice, which is equivalent to 0.12. So when I plug into my formula here, I have y equals that 20,000 for a times 1 minus 0.12 to the x. And now we know what x is. It's after 3 years. So I'm going to plug that in for x. And I want you guys to type that into your calculator and tell me what you get. So type that into the calc. This straight into your home screen. What do you get for y? Good. You should get 13,629.44. We round to the nearest cent. Okay? All right, awesome. All right, let's take a look at question 16. And now, guys, just make sure your answer makes sense. This is talking about something that decreased, so I would hope my answer choice is smaller than the starting amount. All right, so this should be smaller than my starting amount because it's decreasing. Okay, let's look at 16. We have a position at a local company has a starting salary. So there's your initial amount. So there's my A value. We're starting at 15,000. And we're expected to increase. So I'm looking at a growth. So I know I'm using my formula. Y equals A times 1 plus R to the X. And it's growing by 5%. So we know our rate is 5. But I want to turn that into a decimal. We move the decimal 2 places to the left, so that's equal to 0.05. Okay, so R is equal to 0.05. And we want to know what will the salary be after 5 years. So we know X is 5. We have all of our pieces, guys, to plug in. So let's do it. I have Y equals 15,000 times 1 plus our rate of 0.05 to the 5th. And now when you type that into your calculator, you should get y equals 19,144.22. Again, we round to the nearest penny. All right, round to the nearest penny. And guys, that's all I have in store for us today. So these questions about sums up, how to check for exponential growth and decay. You guys just got to remember the difference between the growth and decay model. So when I'm looking at a growth, remember, when I'm looking at a growth, if I have y equals ab to the x, if this number is bigger than 1, we're looking at a growth. So I'm now looking at this formula, y equals a times 1 plus r to the x, where r is written as a decimal value. If I have y equals ab to the x is less than 1 for that b value, okay, so if that value is less than 1, well, now I know I'm looking at a decay. And our formula for decay is y equals a times 1 minus r to the x. And remember that rate has to be written as a decimal, not a percentage. All right, hope this video helped. Talk to you guys soon.